So I'm just going to look at E. Now, when we have factors, I just want you to recall that this can be thought of as one factor, this can be thought of one factor, and my radicand, there's two factors there. Now, the factor b minus 1 cannot be simplified or expressed as a perfect square. It's just a factor. However, maybe I'm going to ask if my coefficients 25a squared and 4 can be thought of as perfect squares. And indeed they can. 25a squared is a perfect square, and 4 is a perfect square. So what I'm going to do is I'm just going to simply decompose my radical in the following way. Plus a, now I'm just going to say times the square root of 4 times the square root of b minus 1. I'm going to take a look at this first expression right here, and I recognize that the square root of 25a is 5a. And I'm just going to leave the square root of b minus 1 plus a, square root of 4 is times 2 times the square root of b minus 1. Now we're almost there. I just need to simplify some stuff. So this is really 5a times the square root of b minus 1 plus 2a times the square root of b minus 1. I'm going to combine this together and just say, well, my radicand is going to stay the same. Sorry, incorrect radicand. It is going to be b minus 1, and then 5a, the root of b minus 1, plus 2a times the square root of b minus 1. It's going to be 7a times the square root of b minus 1. Hopefully this is helping. Now, binomials make things a little bit more difficult just by appearance, but really all we're dealing with is factors. Perhaps our last example will be g. Now, g really looks intimidating. However, let's keep our mind about ourselves. So what we're dealing with is cube roots. Definitely that gives us an indication of what we should do. So just for fun, I'm just going to recall our perfect cubes. There they are. 8, 27, 64, 125, and 216. Now, 216 is 6 cubed. Now, I'm just going to simplify all of this going forward. So this is, I'm going to start on my question. So that's 27p is my coefficient times the cube root of q cubed times p plus 8q times the cube root of 216 times p to the power 3 times p. Now, I'm just going to highlight perfect cubes here. This was a perfect cube. 216 was a perfect cube. Now, I had a feeling that 216 would have been a perfect cube, simply because if it wasn't, I wouldn't be able to combine like terms. Oh, and also from p to the power 4, p to the power 3 is also a perfect cube. So I'm just going to maybe settle all of this up. I'm going to simplify this. This is 27p. Now, perhaps we're getting really well acquainted with this cube root business. The cube root of q to the power 3, I'm going to decompose that, times the cube root of p plus 8q. Now, I'm going to split this up into the cube root of 216 3p times the cube root, now I better include my index, of p. Now, I'm just going to maybe simplify things that I can. So this is 27p. I'm just going to leave that as it is. Now, the cube root of q cubed is q. Now, the cube root of p is just simply the cube root of p plus 8q. Now, that's not very exciting. However, the cube root of 216p cubed is better known as 6p. So I'm going to put that in brackets. So I have a whole bunch of factors going on. Sometimes we just like to include brackets to solidify things. Last but not least, I have the cube root of p. Now, I'm just going to isolate our radical and recognize that the index and the radicand is the same. So we are in business. So we have like terms. I'm just going to clarify the coefficients. So this is really 27pq, the cube root of P plus 8 cubed times 6P is, 8 times 6 is 48 PQ times the cube root of P. Okay, so I'm struggling a little bit here. 27 plus 48. Sometimes you just got to do what you got to do, and this addition algorithm certainly works. So that is 8 plus 7 is 15. Carry the 1. 1, 4, 2, and I believe that's 7. So this is 75 PQ, the cube root of P.